Welcome, madam.
Yeah, thank you. Very good morning to one and all.
Morning,
Good
madam.
morning.
Good morning.
Good morning, madam.
Morning, sir.
Madam, shall we start?
Yes, sir. Yes.
Respected chief guest, respected director, and my dear colleagues, good morning to all. National Technology Day is celebrated every year on May 11 to highlight the achievements of engineers and scientists in the field of technology and science. This is to commemorate our country's three successful nuclear tests at the Indian Army's Pokhran test range under Operation Shakti in the state of Rajasthan on May 11, 1998. This year we are celebrating Technology Day with the theme of Integrated Approach in Science and Technology for Sustainable Future. To begin today's event, I request our director, Dr. Srimati N. Anandavali, to present over the function and give a welcome address.
Thank you, Dr. Satish Kumar. Chief guest of today's function, Professor Akila, Director, National Institute of Technology, Tiruchirappalli. Advisor Management, Dr. Bharat Kumar. Head, Business and Knowledge Management Division, Dr. Satish Kumar. Heads of the laboratories, scientists in charge of the regional units of CSIR Madras Complex, scientists and staff of CSIR Structural Engineering Research Center and CSIR Madras Complex and its participating units. Ladies and gentlemen, a good morning to you all. It is indeed a great pleasure to welcome you all on this special occasion of National Technology Day. National Technology Day is celebrated on May 11th every year to commemorate the achievements of scientists, researchers, engineers, and all others involved in the field of science and technology. It is a day to remind Indians about the technological advancement made by the country. The day marks the anniversary of the Pokhran nuclear tests, Operation Shakti, under the leadership of aerospace engineer and President APJ Abdul Kalam. In 1998, on this day, India became the sixth country to join the nuclear club. After its successful test, the then Prime Minister Atal Bihari Vajpayee coined the term National Technology Day. On the same day, Hansa 3, India's first indigenous aircraft, was first tested in Bangalore. It was the first of its kind two-seater general aviation plane used for flight training and personal flying. Successful test firing of Trishul, a short-range missile made in India, was also done on the same day. National Technology Day was first observed on 11th May 1999. The theme for 2022 National Technology Day is Integrated Approach in Science and Technology for Sustainable Future. The theme was launched by Honorable Union Minister Jitendra Singh. Structural engineering has a big role to play in this effort for ensuring sustainable future of our society through sustainable infrastructure development. Transforming scientific breakthroughs into new technologies can have a profound impact on development, but wise stewardship of these technologies is essential. One challenge of sustainable development is to use technology in such a way that it balances advances in productivity with long-term resource viability. Science and technology is crucial to tackle complex challenges for humanity, such as climate change, biodiversity loss, pollution, and poverty reduction, as it lays the foundation for new approaches and solutions. Transforming scientific breakthroughs into new technologies can have a profound impact on development. One challenge of sustainable development is to use technology that doesn't harm the nature. This critical role for sustainability science as it promotes cross-disciplinary approaches to advance the understanding of the human-environment interactions and systems and how these interactions affect the challenge of sustainability. Today, India is also increasingly assuming a global role and as Honorable Prime Minister has reiterating at every available forum that we have to come out of the culture of working in silos. Now, to come out of silos is no longer a matter of only option, but or by choice. It is a necessity. Today, indeed, we are very fortunate to have Professor Akila, Director, National Institute of Technology, with us to celebrate this year's National Technology Day. I thank you, Madam, for accepting our invitation amidst your busy schedule. Professor Aguila is from Computer Science and Engineering background, and I welcome you, Professor. I once again welcome you all and conclude with a Thirukural, Epporul Ettanmayadayinum, Apporul Meipporul Kanbadarivu, which means analyzing the information, understanding the meaning, and accepting the fact will help one to gain profound knowledge. Hence, true knowledge is the ability to understand the truth behind people, things, and events. Thank you.
Now, I request Dr. B.H. Bharat Kumar, Chief Scientist and Advisor Management, to introduce the Chief Guest.
Thank you, Satish. I am delighted to introduce our Chief Guest, Dr. G. Akila, the second Woman Director of National Institute of Trichinopalli and shortly known as NIT Trichy. She graduated from Tyagaraja College of Engineering and subject was Computer Science in the year 1988 and PhD from Anna University, Chennai. Dr. Akila served as Registrar in charge of NIT Puducherry, where she was Professor of Computer Science and Engineering. She has contributed significantly to the field of blockchain, big data analytics, ontology engineering, and AI. Dr. Akila brings with her the wealth of 32 years career in which she has carved a niche as both an academic and an administrator. Under her dynamic leadership, the 57 years old Institute NIT Trichinopalli, which is the 9th best NIRF ranked engineering institute, is poised to reach greater height. While taking charge, she has said that her priority is to make NIT Trichy more visible at the national and global level. Now I request Dr. G. Akila to deliver National Technology Day's lecture on role of data science and structural health monitoring. Thank you. Over to Madam.
Okay, thank you for the introduction. First of all, am I audible?
Yes, Madam.
Okay. A very warm good morning to this August gathering. Indeed, it's my pleasure to be part of this your national, that is our National Day or Technology Celebration Day, and it gives me immense pleasure to be among with you people, because you, the institute, as doing the bridge monitoring or whatever the high level structures to the available in overall or all over India. Basically, I am a computer science person, but the civil engineering aspect, whatever I know, I would like to give you my view of what is the role of data science in structural health monitoring. So in that, it has been divided into two things. One is initially talking about all the techniques available, then linking. So I do not know the expertise available in your team. Maybe already you may be working with some of the tools or some of the techniques. So it will be like a recharging or refreshing all those things, and we will get into it. So generally, before starting, because this is a National Technology Day and this is my first kind of this program, so I also added about what is the National Technology Day, when it started. So with your permission, I'll be skipping all those slides. Okay, I'll share the slide now. Just you please tell me whether you could see it or not. Could you see the slides?
Yes, Madam, it is visible.
Yes, Madam. Yes.
Okay. And thank you once again. I thank everyone for giving me this opportunity. When we talk about the role of data science in structural health monitoring techniques, or I can take in this way, the structural health monitoring based on data science techniques, both we could take it. Both have a perspective, it differs. Let us get into it. So in this figure, if you see, the big data is there, machine learning is there, infrastructure is there. So as the team in your team, you must be definitely knowing about the infrastructure and maybe some of the machine learning techniques and what is big data. Let us get into the content. So that's what I told, because this is the National Technology Day 2022. As in her speech, madam, she has pointed out why on May 11th every year this National Technology Day is being celebrated. So I am skipping these slides, because it's the first time I have collected all those things. So I was overwhelmed to give that information. Okay. So coming to the civil structures, you civil engineers, you will see it in a different way. But being the computer science people, we see that as an application domain and we will look into it. So civil structures are currently, whenever any big structure is there, they are currently facing issues related to aging, material deterioration, excessive loading conditions, unexpected at the design stage, inappropriate usage, and environmental actions and natural hazards. So what is required right now is how to tackle these issues. Maybe we have to get into an automatic system or semi-automatic or fully manual. The issues available here are, whenever we would like to get the information, when we are getting, what are all the preventive actions we could do or we are doing, and how that particular process could be enhanced. These are all the things it should be available in our mind before getting into what is the role of this data science in health monitoring. So under these circumstances, the structures may get affected by serious damages which threaten their structural performance and safety. All these parameters, the expertise people, you know it very well. So to avoid irreparable events and guarantee the serviceability of the structures, structural health monitoring, SHM, represents a practical tool to evaluate the structural conditions both at the global and the local levels. So here these slides get into some more information. That is it a single discipline? Definitely no, it is a multi-discipline field. Why we are telling that it is a multi-discipline field is because it involves the automatic sensing of structural loads and response by means of a large number of sensors and instruments. Now the sensors are coming into picture, IoT is coming there, and followed by a diagnosis of the structural health based on the collected data. Now we have to understand here how we can monitor the health of the structure. Is it from the place where I am working, or we have to go to the place where it is happening? But what we want a system is, in future, that could be monitored from anywhere, any place, any location. That is the kind of system we need. So if we need a system like that, what are all the information or what are all the knowledge is required or knowledge to be stored? Right now, a person, an expert, whatever he is having in his mind or she is having in her mind, that has to be represented in a computer, represented in the sense it has to be stored in the computer, and appropriately whenever it is required, that has to be extracted or derived from the data. So generally, from the computer science perspective, we will talk about data, information and knowledge. Data is different, information is different and knowledge is different. As an example, with numbers, if I say 1105 2022, it's only number. It's a raw data. But what is that information? The information is, it is the date, or it may be an employee ID, or it may be the some other number which represents the employee ID, whatever it is. But what is knowledge? How I can say, or what is the knowledge from this? So if I know the significance of this data, the knowledge here, it is nothing but that is the day when the National Technology Day is being celebrated. The system, what it will store is only the number, the data, Then the additional information with the type of the data, it will identify that it is a date, so it represents some date. What is the knowledge is nothing but it is the National Technology Day, or it may be a birthday of some of the employees in your institute or in your organization. Like that, that is going to be the knowledge. But what we want is in the structural health monitoring, whatever the information is available with the system, it has to give a best result out of it. The best result in the sense, in the structural health monitoring, it has to give us the information. Maybe after 2 years or maybe after 2 months, you can expect some kind of crack in this place, or you can, because it is deteriorating. This kind of inference we would like to get. That's what we want. That's where we can think of how the data science is going to help in structural health monitoring. So if you see this, the techniques related to massive data are referred to as the data science and engineering. So when I say the data, I talked about only a simple data, the date. But you know the massive structure available with you because all the FEM analysis, everything you are doing. But the problem here is what is the data available with us, what we are storing, and apart from that, the time is also important when the data is being collected. So we need a system from the computer science angle. Whenever we see that all the data capturing, generally we'll call it as data acquisition, that is going to be an important part. In the data acquisition, whatever we are acquiring, it is in which form, what is the next step? The next step is we have to do the pre-processing. As a civil engineer, definitely people will not be worried about what kind of pre-processing we are supposed to do. But it is important to know that what is happening inside so that the correct data in the correct format will be given. So the techniques related to this massive data are referred to as the data science and engineering. With simply 1K of data or 1 GB of data, and when it gets into terabytes of data, the analysis is going to be a massive computational requirement is there. So when we talk about this data science, including the data acquisition techniques and transition technique is nothing but the pre-processing and transforming those data to do my processing in a meaningful and the best way, and the management techniques and processing those things, and after while doing the processing, any mining we can do for the massive data. From the computer science angle, when we see this, whenever the data is available, what are all the various techniques available and how we can do it. And people, all the civil engineers, you would have, during your course itself, nowadays they are doing the soft computing techniques. So how we could relate it? These are all the things we are going to look into it. So the modern structural health monitoring paradigm of transforming in situ real-time data acquisition into actionable decisions regarding structural performance, health state, maintenance or life cycle assessment has been accelerated by the rapid growth of big data availability and advanced data science. So what is it available? So such data availability coupled with a wide variety of machine learning and data analytic techniques have led to rapid advancement of how this SHM is executed, enabling increased transformation from research to practice. In research, so many techniques are being practiced and they are following it also. The next slides or the following slides give you an overview of what are all the various techniques available. Right now, you may think that why I should know about this. Whenever any icon or any technique is being given, simply I'll be applying that and I'll get an output. Whenever I'm getting an output, as an expert in that field, whether is it correct or not, is it giving correctly or not, why it is giving, this analysis we are supposed to do. So only if the data we are giving it in the correct data or the required data in the correct format, then only I'll get the result. So that is called mapping. That is an one of the important technique in data science. So again, some more information. SHM is an incredibly new technology that has grown over the last decades. The ability to discern damage at the start stage can reduce the cost and time associated with the fixing of basic damages. All these things practically you people are encountering. But here we have to think about that artificial intelligence. Now I am introducing the word AI, artificial intelligence, which has a long history in computer science. It provides a wide variety of methods for coping up with monitoring problems that would be difficult to solve by conventional computational techniques alone. So what is this AI? What we expect from AI? The definition of AI goes like this: making a machine to think like a man or think like human. That's all. That's the basic word for artificial intelligence. Is it possible? Can I make a machine to think like a human being or a man or whatever it is? You would have heard about so many techniques that like swarm intelligence, ant technique, or there are so many techniques available. But if we want to make a machine to think like a man, what is important? Apart from computational and all those things, the knowledge or the data or the information the particular machine, whatever it has, is important. So without the data, we cannot make the machine to think like a man. So that's why we are concentrating on the data science. So if we take for the world knowledge, storing the world knowledge is completely a different what is it? It's a technique, and there are different techniques available. But here we are very much into structural health monitoring. So if we take that domain alone, even in your civil engineering itself, there are many domains available. But in the structural health monitoring, we may be requiring only very few information like this. So we are narrowing down the domain knowledge or domain information or the domain data. So whenever we go for this structural health monitoring, the important information what we have to have in our mind is what is the data I am giving. With that data, how I can apply this AI technique so that a person is there, an expert is there in that place, how that person will be thinking and giving the solution. Same way, my system has to give me some suggestions. This is our requirement. So in this, this physics-based approach, it's a different one. Let us not get into this. But the availability of the historical data has engendered a lot of interest in a data-driven approach as a natural and more viable option for realizing the goal of SHM in such structures. So the important thing here we have to get into is the data-driven approach. So we have to talk about only the data. That's where the data science is coming in. Data science and engineering is coming into picture because of the voluminous of the data the system has to compute. So the recent advances in sensor and information technologies have opened up the possibility of exploiting big data in order to shift the focus from sensing and instrumentation to the analysis and interpretation of sensor network outcomes via this data-driven methods. So it's nothing but let us not confuse it with what is this data-driven methods. With the available data, we have to make a conclusion. That's all. But the voluminous of the data is important here. The high dimensional data, large volume of high dimensional data, and accessing or having an algorithm which has to work on this high dimensional data, it requires a lot of pre-processing whose size is beyond the ability of commonly used software and hardware to analyze the samples in a limited amount of time. So if we assume that we have the computational power, whatever it is required, it is available with us, we are concentrating only on the data side. So the concept of big data has received remarkable attention when dealing with complex engineering problems, also within the civil engineering community, not only the structural health monitoring, in other areas as well. So this big data may arise from SHM in the case of long-term monitoring strategies, use of dense sensor networks. I hope already in your organization you may be using so many sensors in the place, so that the sensor data you will be acquiring and some kind of analysis you will be doing and the results will be given. So the exploitation of multiple dynamic tests on the structure and high sampling rates, these are all the importance. Just we have to get into the big data analytics. So big data analytics for SHM is a relatively new research topic. That's what in 2019 told, but this is the paper which I have referred. But within 2 years, I think a lot of advancements are going on. There are a lot of YouTube channels are available where how they are doing the very big structure of in structural health monitoring. Wherever a human, they cannot go to the place whenever we need the data. So they are fixing the sensors. Whenever we are fixing the sensor, whether it has to be embedded or only at the time of getting the data, that has to be fixed and we will be removing the sensors, or whether if a man could not approach that place, we will be putting the sensors on the maybe under the bridge or over the bridge, because the bridge structure is an important one. Right now, I would like to share some information with you, because that whenever we would like to get the data from under the sea, any sensor information, how the sensors are being put up there in under the sea, that's the biggest question in everyone's mind. So generally, they will put the sensors from maybe from the highest level, or from they'll go and put the sensors. It cannot be embedded inside, or it cannot be put inside the earth or under the sea. That simply they will go and put it, that's all. So they have some more techniques so that that sensor will be there in that place. If any damage happens to that sensors, we will not get the data, that's all. And the time, everything is being fixed. So we will be receiving the data. Okay, so this big data analytics for SHM, the data, whatever the data we are getting, why we are talking that this is a big challenge, because the variety, type and nature of data coming from different sources. The different source may be a sensor, or maybe a person going there and getting the data, or through the image processing, or through the photograph we may get the data. So the variety of the data will be getting from various places, and the volume, the size and quantity of that data, and the velocity, speed at which the data or we are getting and we are processing, that is an important one. Whenever it is going to be in real-time processing, the speed we are getting and the processing we are doing, that is an important aspect we have to think into, and the complexity which is related to uncertainties and inaccuracies in them. So whenever we are getting the data now here, clearly assuming that whatever the data we are getting, it is perfect and it is accurate, but may not be. Because sometimes we may not get the data, that will only the void or the null value will be there, and sometimes whatever the data we are getting, it may be an uncertain data. In those cases, how it could be processed, that AI, there are some more techniques available in AI to handle all those things. But what we have to have in our right now in our mind is the voluminous of the data we have to process. So the challenges are the lack of sensor data corresponding to different damages. Okay, coming to health monitoring, only the damages we would like to monitor. Then the data corresponding to different damage scenarios continues to remain a challenge. That's what I told, how to keep that sensor, whether that has to be permanently embedded. If it is permanently embedded, how frequently we have to change the sensors, the validity of the sensor, the type of the sensor we are using, and all those things are it should not be a challenge. That has to be analyzed, and for the requirement as an expert in that domain, or we can get the information from the other domain people to fix the type of the sensor that has to be fixed, and the way how it could be embedded, or just we can fix it and after getting the data we can remove it and come. All those things, the decision we have to make it depending on the requirement. But here the challenge here is, whenever we are getting the data, the current data, real-time data, what is the past history is available, that is also an important. Why it is important right now is the big picture of the structural health monitoring indicating that as the complexity of the structure increases, and exclusive reliance on the system physics for analyzing the measured sensor data is reduced, and an approach that is primarily data driven is okay. The challenge here with the fixing the sensor, with that we will stop. An optimal approach for large complex real world structures must be data driven with the system physics domain knowledge embedded in some form. Okay. So the objective is structural health monitoring provides a useful tool for ensuring integrity and safety, detecting the evolution of damage and estimating performance deterioration of civil structures. Okay. The components, once we get into it, this is structure, data acquisition system, data transfer system, data digital processing and storage of data, and data diagnostic. In this place, I would like to give you some more information. Generally, you will call it as small damages. I hope the BVID you must be using. Whenever the damage size is this much, or I think 0.01 to 0.02 inches, it will be called as BVID. Whether here in civil engineering you will be using it or not, this data I got it for the structural health monitoring of the aircraft system. So in that they are telling that the BVID is small damages which is not visible from 5 feet, and the dent depth is 0.01 to 0.02 inches. So based on the damage size, that BVID, now we can go for some of the techniques. Why it is required is based on this, the amount of data we are collecting, it will vary. So, okay, now we will assume that we have a fantastic data acquisition system. Now we have got the data, maybe for the past 1 year or 2 years, with time and data, it's a real time. Now we have to imagine the voluminous of the data. With the data, what is the output is expected? What do you want? Maybe the damage not detectable, that may be one category. The damage detectable, the damage readily detectable, or the damage immediately detectable, and it's a very large damage. This is one kind of classification we can give. So what is meant by damage not detectable is from the data, whatever we are, for example, if the data is only the photograph which has been taken from a certain distance, from the photograph, now expert has to see the data photograph, and they have to find out whether any damage is there, visible damage is there. Only the visible damage we could. So the damage not detectable is if it is not being seen outside, then it is very difficult to detect that damage. In that category, when it will come, that is the damage, whatever it has been occurred there, 1 year back, that may not be there. After 1 year, a small crack may be there. So this is the kind of evolution, or this is the kind of readily that is through the human eyes or through the camera we can witness it. So that is the detectable damage. So one with the data, now I can give it as an output. These are the various classification. Now I am introducing the word classification because that is not a human, okay, the data whatever we are giving, it cannot immediately come and tell you that these are all the things you have to do it at the next level. Suggestions it can give, that we have to have again one more system. But with this data, what is the output we will be getting is, if I get the information, immediately something has to be addressed in that place, or something has to be done in this particular portion, then we will be very happy with that information. Generally, this will come under the expert system. That is the output whatever we are using. You might have heard about the word expert system also. Again, if the expert system want to work correctly, it has to do the diagnosis, it has to do the prognosis, it has to go for the life extension and predictive maintenance. This is the cycle which they have to follow in the expert system. So in this particular scenario, what is the challenge for the people who are working in this is, what is the type of sensor we have to select? And what are all the various acquisition units available, which one we have to select? And how to install it, that installation procedure. and the miniaturization or making a model or a model building. These are all the various technology selection for that the people who are working in your organization or in any organization with the knowledge of the domain knowledge, it should be possible for them at least to clearly tell what is the requirement. So once if the requirement is being given, selecting the type of sensors and the acquisition methods and the installation procedure and the miniaturization could be done. So in this, what are the various development in the methodologies available from the computer science angle? The level one is detection of damage existence. Okay, that's one level of requirement. It can detect the damage existence. And it can detect the damage location. That is also important. And it has to detect the damage size and the damage characteristics also could be given. That's as an output. These are the various levels of the output, whatever we think about. And the influence of this on the residual strength. So what we have seen right now is two things. The technology selection, in that all the type of starts with types of sensors. Once all the data is available, then up to which level we need. There are various methodologies available. So we need the methodology or the development of the methodology, whether I want to go for only detection of damage existence or detection of damage location or its size or its characteristics and influence on the residual strength. These are all the various requirements. You can think, yes, I need all these things. We can very well say that, yes, I need all the outputs. It's not, I cannot fix that it's only damage existence, it has to be. Then the output will be yes or no, whether damage is there or not. But to do any action on it, we need the location, then we need the size of it, and we need the characteristics of that particular damage so that the correct solution could be given. So in this particular selection methodology development, the requirement is the reliability, the proof of detection, and there are so many techniques available, and the cost benefit analysis. These are all the important requirement we have to think about. The reliability, of course, we know once if the system is not reliable, then people or we cannot use it. So these are all the things available whenever I go and select a particular technique or a methodology for going for structural health monitoring. So once if all the information is available, now let us get into what are all the various techniques available. Computer application in structural engineering. So at present, major work of structural engineering such as analysis and design of the structure is done using so many computing tools, and you may be using all those things. Okay, already you people are using it, FEM software and then ANSYS and all those things. Okay. And this is generally AI in engineering domains, the machine learning, pattern recognition, deep learning. These are all the three things now I'm introducing you people, because right now as a for the health monitoring, structural health monitoring, we have the data, we have decided on what are all the various types of sensors we are going to use, and the data acquisition is over now, and we have done the pre-processing also. Now the data is available with me. Now is there any AI technique is available to work on this data so that whatever it is required, that could be given to, or that could be given as an output. So if you see this applications of ML, PR and DL in structural engineering, artificial intelligence, machine learning and pattern recognition, you might be heard about all these words. Deep learning architectures, it is available. So the current applications are structural health monitoring, damage identification, and even in earthquake engineering, the structural identification and modeling and predicting concrete materials. They are using the machine learning and pattern recognition techniques for this. And using this deep learning architectures, vision-based structural health monitoring and the structural analysis. So the emerging applications are data-driven or IoT structural health monitoring, or only using the computational mechanics. And if you see the structural analysis, It may be using the computational mechanics, IoT, smart cities, and vision-based SHM. These are all the emerging applications available using the techniques which are available in the artificial intelligence. Directly, there are so many algorithms available, but here we are looking into only the machine learning and pattern recognition techniques and deep learning architectures. You may think, what is deep learning? What is this machine learning? So this will give you an overall picture of the connection between all those things, whatever we have talked about. So if you see the bigger circle is the artificial intelligence. Inside that, the machine learning is available. Inside that, the deep learning is available. But the data mining and the science is part of it, and the big data is, because without the data, no technique can work on it. That's what this tells. But this big data, where raw data could not be given, that has to be pre-processed and it has to be given for all those things. Now, the next question is, this is in 2018 paper only I got it. The recent work, your 2022 work, actually I could not get. So maybe when I am coming there for directly before that, I will collect some more information what is currently going on, and I can discuss with you so that I can enhance my knowledge also. So this already we have seen that overview of the artificial intelligence, which is just I'll skip it. But the main goals of AI research involve knowledge representation, reasoning, automated planning, learning, natural language processing, perception, robotics, and general intelligence. This is very, very generically. But if we get into our structural health monitoring, we need the output in such a fashion that at the highest level, if it is level 1, it has to say yes, damage is there or not. Or at least if I go for the level 1, it has to tell it is in this place, it's available. And at the third level, the size of the damage also could be given. And at the fourth level, the characteristics of the damage also be given. So based on the analysis, based on our requirement, that level could be fixed, and based on that only we have to select some of the methods available. So if the classification is the machine learning, pattern recognition, neural networks, fuzzy logic, evolutionary computation, deep learning, expert systems, probability theory, discriminant analysis, swarm optimization, and meta-heuristic optimization and Bayesian trees have been used in structural. These are all the so many soft computing techniques. Already people who have completed your soft computing techniques in your UG or PG, you would have come across with. But right now, the important one is for the work, day-to-day work you are doing, can I apply any one of the method available so that that is going to ease my work? But whenever I am applying it, how reliable it is? These are all the things, it will be available in everyone's mind, whether I can go for it or not. Okay. So this is an information in 2018, the research publication on the use of different AI branches in structural engineering. This I got it from that Saheli 2018 paper. But they have very clearly, they have established that AI method can help minimize time-consuming laboratory or field tests to determine design parameters. Okay, in that way they have given. And some of the AI technique used in structural engineering or pattern recognition, machine learning, and deep learning. That's what already we have talked about. If we take the pattern recognition, what is generally the technique of PR is, the main goal is to classify objects into a number of classes or categories. So in our structural health monitoring, where the classification come into picture, where the categorization come into picture. If you see the flow chart here, from the input, okay, the input is being given to sensing and segmentation and feature extraction and classification and post-processing and the decision. So what is the decision in this pattern recognition? If you give a kind of pattern, if it repeats, then system has to identify this is the pattern, input pattern, and the same pattern it gives, and so that whatever already in the history it has happened, it may come. Generally, the pattern recognition technique as a human being, we are applying in day-to-day life and we are making some decision. But here the question is whether it could be used for or used in structural health monitoring. Definitely, it could be used in structural health monitoring, damage detection, and earthquake engineering. So what is that PR is? It's PR is collecting and processing the group of information obtained from the sensors of structural health monitoring and finds the relation between the obtained signal with the state of the structure. So this pattern recognition now, to simplify the thinking of us, it's very simple. The original one will be there, original and that is pure one, not damaged one. Whenever any damaged photograph, for example, if the input is in the photograph, not the data, not the values, if it is photograph, when the two photographs are being given to an expert, the original one and the current one, then by looking into those photographs with the outside by open vision, the expert can tell, yes, the structure is deteriorating or already deteriorated, the percentage of deterioration may be like this. So what kind of processing is going in his mind, that is an important. He is applying some kind of pattern recognition. Originally it should be like this, but now it is like that. So there may be a probability is being associated in his calculation, and already he would have, with his vast experience or with her vast experience, this it should be like this, but it is not like this. So the percentage of deterioration is this much, or there is no deterioration. They are getting into the pattern recognition technique they are applying in their mind, and they are doing. Okay. So how it is being done? Computer, how it does? It is simply represented by a set of features. So the concepts from statistical decision theory are used to establish decision boundaries between pattern classes. The recognition system in PR consists of two modes, namely learning and classification, or we will call it as training and testing, which these two words we know. Because now I want to think my system to become an expert in structural health monitoring, I have to train the system. How I can train it? With the available or the historical data. In this juncture, I would like to give a small example what is that training and testing. Imagine a 1-year-old baby or a small child, where that child would have not seen the cat or tiger, whatever it is, that category of animals that child would have not seen. So we are giving the training to the person only, or to the child only, with the cat picture. So we will be giving the cat picture like so many cats and colors and everything. And suddenly in the testing phase, instead of giving a cat picture, if I am giving a tiger picture to that child, what the child may say? The answer is, it may say it's a cat with some of the lines on its body. That may be one expected answer. But other answer may be, if that child understood that the pattern on the outside, it may be anything. So it is a big cat. These are the two kind of answer we can expect. That is, we have not trained the child with a tiger picture. We have trained the child only with the cat picture, and we are giving, in the testing phase, we are giving the tiger picture. So the expected answer is, the child may tell it's a big cat, or the child may give the answer cat with different lines on its body, or the colored lines, or with the color the child can distinguish. Which one is the right answer? We do not know right now, because that child has not been trained with the word tiger. But if we expect the child has to tell the answer tiger, is it possible? Definitely no. So this is the importance of the training and the testing. So whenever I would like, because it's the same case, if there is a crack, if there is some damage is available in the structure, we expect that the system has to give, this is the kind of damage. But the training is required. So what are all the various training techniques available? That lot of information is available in our literature. Okay, the same question. If we give train the child, instead of the cat picture, if you are training the child only with the tiger, and again we are in the testing phase, we are showing the cat picture, what is the kind of answer we can expect from the child? Now the child may tell it is the small tiger, or small tiger with lines. Is it a right answer? Because that child have not been trained with the cat picture alone. So this is the importance why I have given this information is the importance of training the set is important. Whenever any domain data is available, the training phase, whatever we are giving in the testing, when it is being given, that system can tell immediately. In the training, if we could not give that is while testing, if I give an unexpected or which has not been trained, which is not similar to the trained one also, then the system may give an answer in a different way, which is not we want. That's how the system we are working right now. So the important one we have to understand is the training set and the testing set. What is the training set and testing? Again, it comes into the data. The data is very important. Whatever the technique you are using it in artificial intelligence or soft computing techniques, the importance of the data is to be understood, and with what data we are training, and while testing what data we are giving. These are all the important observation only the expert and that people can give. As a computer science engineer, because we lack the domain knowledge of the structural health monitoring, the expert in structural health monitoring, they have to give that input to those people. Then only we can make the system to learn, and the testing will give it in a better way and best way. And classification. Okay. I hope now in the pattern recognition or in general, I have given the information what is the importance or the significance of the data, and how I can, or what is the need to train, that is classification of the training data set and the testing data set. And whenever any data set is being given, whichever not be given using the training and the testing, then how the system will work, what are all the techniques available in computer science engineering is pattern recognition we will get into. In the machine learning we will come. So the different techniques available are this one: supervised learning, unsupervised learning, and reinforcement learning. So in the supervised learning, so why this is important for the domain experts from structural health monitoring, you have to understand is, if you give this input correctly, then we can select the correct technique for the requirement of you. And whenever it is not meeting, the domain experts can very clearly say that this is our requirement, this is the data we are giving you, tell which technique could be used. Then the person who is with the other domain knowledge, or the expert in that computer science or whomever it is, they could clearly advise, or they can clearly give a suggestion whether for this kind of experiment or this kind of requirement we can go for supervised learning or unsupervised learning and reinforcement learning. But suddenly I have used the word learning. So far I have not used the word learning. But the role of data science in structural health monitoring, with the data, what we are trying to do is we are trying to teach the system. So that's why whenever the teaching is there, the system has to learn it's automatically. There are different kinds of learning methods available: supervised learning, unsupervised learning, and reinforcement learning. If I take the same example of cat and the tiger, without telling the child that this is cat, simply you give some pictures of cat, dog, and one more animal, maybe rabbit, you give. So what the child will do in his mind, because now we have not labeled that, we have not told the child this is cat, this is dog, and this is rabbit. So what the child will do in his mind is, that's how the system will work. Okay, all these are similar cats, so it will cluster that as a cat, and cluster all the dogs as a one cluster, and all the rabbits as one cluster. So now it is an unsupervised learning. So the label, it has not been given, but in the child mind, it will understand that, okay, all these things comes into one group, other group. This we'll call it as clustering. So again, that's a kind of learning the child is doing. So what are all the various techniques available in machine learning to go for a learning is supervised, where we will say that this is cat, this is dog, and we will go for the classification, regression, and image classification, predictions, diagnostics, and process optimization. These are all the supervised methods. And in unsupervised methods, we'll do the clustering. In that clustering, we have to go for dimensionality reduction, which I have not talked about it so far. Whenever the multidimensional data is available, the computer for processing the multidimensional data, it needs enormous computational power, main memory, and time. When we cannot give that much time for analysis and all those things, then we need to reduce the dimensionality of the data. So there are so many statistical techniques available that that's a different one. But here we can understand that the type of the learning, we can go for supervised or unsupervised or reinforcement learning. So the reinforcement learning is learning task, skill acquisition, robust navigation, and real-time decision. These are all the classification of the machine learning techniques. So let us not get into the supervised, unsupervised reinforcement learning. We will do it later, maybe another 3 to 4 minutes I will take. So the machine learning in structural engineering, this is some of the information I have got it. Okay, just I would like to introduce the deep learning, where the deep learning is again the subset of the machine learning. So it's a branch of machine learning, is composed of networks that can learn unsupervised from unstructured and unlabeled data. Whenever we are getting into the more domain specific one, this deep learning architecture aims to learn the feature representation from the input data. Everywhere the data comes into picture. So DL is based on deep neural networks with more than one hidden layer. Okay, let me not get into all those details, but already if you know, if you go through this, you can find out what is that CNN, convolutional neural networks, and recurrent neural networks, and autoencoders. These are all the techniques. Right now, let us not get into it, but we can understand that when we need to work on deep into my work, then the deep neural networks we have to use, or we have to get into the deep learning. The deep learning requires the enormous voluminous data where the domain expert we are supposed to give. Let us not get into the conventional neural network, but the architecture finally it will give whether it is class 1, class 2, class 3, class 4. Here you can imagine that what is if it is going to be the classification of the type of damage you are expecting, then each one we can define, and we can tell that in these places class 1 is there, or so many class 1 is there. So depending on our requirement, we can get into. Okay. This is some example I have got it for the tall buildings. So if you see this, the sensor network is there. So where and all to keep the sensors, that is a different one. And modeling, dynamic analysis, optimal sensor placement, and where to keep the sensor, that is a different story that we have. There's a different work, then people have to work on it. So once if the sensor network is available, from that we are acquiring the data. And again in this place, while acquiring the data, whether the sensors are already fixed, embedded there, or we are going to place all the sensors. After collecting the data, we will remove it. All those things, depending on the requirement, we have to do that. And once if the data is acquired, the data analysis and post-processing to be done, and all the data, whatever it is there, that could be stored in a SHM database. So from the data available, now we can go for the analysis of the data, and this is one of the CNN and RNN. So finally, this can be made as a real-time system also, or after collecting the data in offline also we can work on it. These are depending on the requirement of us. We have to think about a system and we have to get into it. So these applications of ML in SHM is like this. So this and all getting into that all the deep learning techniques. Let us not get into it, but this example, if you see the training, the RAD image is available. It's a building data bank, training set and validation state. After that, The trained CNN classifier will give testing on a new image. It may report it like this. We are very much bothered about this portion and this portion, but here I would like to, during this technology day, on this technology day, the importance of the data and the pre-processing and the dimensionality reduction of the data to get my output in a way which I want is important. That's what I would like to emphasize from today's this particular, maybe I won't say it's a complete information I have given, maybe with discussion. These are all the various applications, and the important one is already you would have heard about this 3D printed 3D printers, and in all the places the 3D printers are being used. Then okay, it's an example. There are many advantages for 3D printing. Okay, digital image correlation. The TIC tracks the deformation in the structural element. This is done by continuous analyzing the displacement of the small elements of the whole image of the structural element. So using processed data obtained from DIC, we can get the stress concentration in the structural element. Okay. And this scour monitoring sensors. These are all the various types of sensors, corrosion sensor, and all those things are available. With this, what I would like to conclude is, during this maybe in 45 minutes of whatever I have in my mind with the structural civil engineering aspect, that especially with the structural engineering, the importance of the database when we get into, then it's going to help the other domain people, especially the computer science domain people, so that whatever the output you require in whichever the form that could be given. So the important one is storing the data, and whenever we are storing, how it has to be stored, the pre-processing. These are all the important techniques. So if you get into the intricacies of it, for your requirement, we can design our own system rather than depending on some of the tools available where we do not know what is the technique people are using there. So if we know this, we can develop our own software or our own tool to execute for the work which is required in our place. So with this, I would like to thank you for the opportunity.
Thank you very much, madam. We are indeed honored to listen to your speech, giving brief about data acquisition technique and data analytical methods, highlighting application of data science in the field of structural engineering, particularly in structural health monitoring, which is one of the major research areas of Csir-Serc. Thank you very much. Now I invite Dr. K. Satish Kumar, Chief Scientist and Head BKMD Division, to deliver the vote of thanks.
Before that, I would like to add, Madam, you have given a very good comprehensive talk on SHM and how data science, artificial intelligence, data-driven approach is essential in SHM. And you have started with basically the difference between data, information, and knowledge. And right from that, variety, type of data, speed, uncertainties, and even a novice, after listening to your lecture, will have gained a lot in the area of structural health monitoring and how data science is important. And the highlight is that through the cat and tiger, you have made us understand how we have learned as a child. So how we learned the things. That was, I think, everyone would have got a glimpse how the data is very important in training phase, and how the child interprets, and how that has to be instilled in the machine learning concepts and other things, and how the domain knowledge is important. And as Dr. Satish Kumar was highlighting, one of the thrust areas is structural health monitoring in our research work, and our scientists are involved in the performance evaluation as well as health monitoring of and retrofitting in railway bridges and highway bridges and chimneys, cooling towers, and other areas. So, and it was your talk was an example of how integrated approach will help to get best out of both the domains. Thank you, Madam. And I think over to Dr. Satish Kumar.
Respected chief guest of today's function, Dr. G. Aguila, Director, NIT Trichy, respected Director, CSR, SCRC, and Coordinating Director, CMC, Dr. Anandavalli, Advisor Management, Dr. G.H. Bharat Kumar, my dear colleagues, staff members of CSR family, a very good morning to all of you. It's my privilege to propose word of thanks on this National Day function celebrated every year on 11th May. On behalf of Director, CSR, SCRC, and Coordinating Director, CMC, and staff of CSR, SCRC, and CMC, I would like to extend my heartfelt gratitude to our esteemed guest, Dr. G. Aguila, Director, NIT Trichy, for accepting our invitation and being here with us today in virtual mode for National Technology Day function. Yeah, your lecture on role of data science in structural health monitoring was really very useful to all of us. You have touched upon almost all aspects of structural health monitoring, including artificial intelligence and big data analysis. I hope our young scientists will be get in touch with you to clarify their own doubts. Okay, I think CSR, SCRC is likely to interact with you in our current and future R&D and external consultancy projects. Thank you, ma'am. I thank our director, Dr. Anandavalli, for always supporting us and guiding us. Without her support, it's very difficult to organize such an event. Okay, I'd be failing in my duty if I did not thank my fellow colleagues who have made this day possible. Sincere thanks to all my colleagues, the heads of various departments, including ICT, BKMD, TCC, SHRD, KRD, administration, accounts, stores, and purchase who handled this event throughout in virtual mode for its success. I personally thank my colleague R.D. Satish Kumar for comparing and Lakshmi Purna for event capturing of this function. Finally, I would like to thank all of you present here for making the time to be with us today and helping us making this National Day function a grand success. If I have missed out someone who have contributed directly or indirectly for the successful conductance of this function, it is not intentional, for which I may be excused. Once again, thank you, everyone. Jai Hind.
Thank you, Madam.
Ma'am.
Thank you, Madam. I'll take leave. Okay.
Yeah. Thank you. Thank you.